part 2 in this mini-series on how to select microphones for podcasts and vlogs. In the first part we touched upon dynamic microphones and miniature microphones. Now we finally have the chance to talk about what I would consider more serious microphones, namely pencil microphones, large diaphragm condensers, and shotgun microphones. Now, actually shotgun and pencil microphones are somewhat similar, and they both typically use 19mm or 3/4 inch approximately capsule, while large diaphragm condensers typically use 1 inch or larger capsule, and that's obviously why they're called large diaphragm condensers. Now, it's called large diaphragm condenser, not large capsule condenser. So what is the diaphragm and what is the capsule? Well, if you picture the capsule, it's gonna be mostly just a diaphragm surrounded by a little bit of housing. I'm not talking about actual construction of the capsule. Obviously, a capsule is a very complex thing, and we're not even gonna go into details on how they're constructed, but I'm talking about dimensions right now. And from the standpoint of dimensions, most of the size of the capsule is gonna be the diaphragm, and there's gonna be a little bit of housing around it. So when we talk of large diaphragm condensers, are we talking about large diaphragms or large capsules? Well, sort of the same thing, but also not quite the same thing. And there's not really, I think, any kind of hard definition of exactly what needs to be an inch, or how, or at which point something becomes a large diaphragm condensers. People generally consider 1 inch and larger to be a large diaphragm condenser, but there are condensers, for example, Audio-Technica makes condensers which are smaller than 1 inch no matter how you measure them, and they still call them large diaphragm condensers. So this is not really that important. If something is considered a large diaphragm condenser, then it's a large diaphragm condenser. That's basically it. So think about 1 inch to 30mm on average for them, and about 3/4 inch for pencil microphones and shotgun microphones, and we'll discuss all of them next. Actually, before we can talk about large diaphragm condensers, pencil microphones, and shotguns, I need to briefly talk about pickup patterns that microphones come in, because without that it would really be hard to explain some of the design features of those microphones. So basically, microphones can either be omnidirectional or directional. Omni means all, so omnidirectional means all directional. Omnidirectional microphone picks up sound from all directions. Now that's an oversimplification. In actuality, it would be pretty difficult to design a microphone that picked up sound absolutely equally in all directions, but as a, you could say, first order approximation, omnidirectional picks up in all directions. On the other end of the spectrum, you have shotgun microphone, which picks up sound from only one direction and is designed to have maximum rejection of sound from any other direction. Then also from the directional part of the spectrum, you have the figure 8 pattern microphone, and it's not very commonly used, but the pattern looks like figure 8. It has equal pickup from front and back and zero pickup from the sides. Then the next one is a hypercardioid, which picks up mostly from the front, a little bit from the back. Then a cardioid, which picks up only from the front and sides and nothing from the back. And it's called cardioid because it resembles a heart in the shape of its pickup pattern. So cardiac arrest, cardioid microphone, heart-shaped pickup pattern. And hypercardioid is basically halfway between a cardioid and figure 8. Now, with that in mind, let's talk about pencil microphones. Pencil microphones are typically going to come in omnidirectional cardioid and hypercardioid pickup patterns, with cardioid being by far the most common, but actually cardioid is also the most common type of pickup pattern for microphones in general, not just pencil microphones. However, a pencil type microphone sort of naturally lends itself towards cardioid pickup pattern. So by definition, you cannot have a pencil microphone in shotgun pickup pattern, because then it would be called the shotgun microphone and not a pencil microphone. And also figure 8 pattern, while there are pencil microphones that are sold as figure 8, you cannot really make a perfect figure 8 pattern out of a pencil microphone, and it's not that common for pencil microphones to come in figure 8, although such microphones certainly exist. So what is a pencil microphone? It's basically a tube of aluminum or zinc or any kind of metal that's about 8 inches long and about a little bit less than an inch in diameter. On one end of the tube you plug in a standard XLR microphone connector. On the other end of the tube you have your 3/4 inch or so capsule, and just behind the capsule you're going to have slits that's going to vent the air pressure from behind the back of the capsule. But it's not just the pressure that's being vented, actually it's a waveguide, and it all has to be tuned in such a way that it will produce both the frequency response that's desired and the pickup pattern that's desired. So the air channels inside of the capsule itself, as well as the venting through the slits behind the capsule, is what's going to determine the pickup pattern and the frequency response of this pencil microphone. Now, a shotgun microphone is going to be similar to a pencil, but the tube is not going to stop with the capsule. It's going to continue going forward, maybe another foot or so, depending on the type of shotgun. It's going to be open at the end, and on the sides there's going to be slits. So it's going to shape the waves coming into the capsule in such a way that any sound or at least any sound in the frequency range in which the shotgun is going to be active, coming from the side, is going to enter the interference tube in such a way that inside of it will mostly cancel out, and only the sound coming from head-on from the pickup axis is not going to cancel out and is going to be registered. Well, obviously in reality there's going to be all sorts of problems with this. Nothing is perfect, but that's the idea. And these types of microphones are typically used for video, but not this kind of video. The kind of video where you cannot get close to your subject, or maybe not even for video, but any time where you cannot get close enough to whatever you're filming, you will want this directional type of microphone. For example, if you're recording some sort of a sports event like tennis match, you want to be able to hear the player and the ball getting squashed, but you cannot really be on the court. So you have to be able to pick the sound up from maybe 50 feet away or so, and that's what shotgun microphones are for. Unfortunately, they just look so fucking cool that a lot of idiots use them when they're really not called for, simply because they want something cool looking. And I'm not gonna name any names, although there is one particular model of shotgun microphone, Sennheiser MKH416, which is legitimately used in voiceover applications, meaning when you sit right next to it and not from far away. And it just, for some reason that nobody was able to explain the reason to me, but for some reason it tends to produce very good results for voiceover. So it's used for that. But normally you would not be using a shotgun microphone in this type of application. However, a lot of people who have no clue, they just know that this type of microphone is associated with video recording, but they don't understand why. The reason why it's associated with video recording is because in video you usually cannot get the microphone close to the subject. But I see all the time on YouTube people using shotgun microphones from half a foot away from their face, and that basically that technically rather is wrong. Although sometimes, as I said, there are exceptions to everything, and sometimes there is legitimate use for a shotgun microphone close up like this. But I would venture a guess that 90% of people I see using shotgun microphones on YouTube or from a close-up distance are just fucking clueless. So finally we can talk about large diaphragm condensers, or LDC, which, as I said, is the type of microphone I'm using right now. It's also probably the most complex and expensive type of microphone, although this particular one is not that expensive. It is a microphone that's most suited for voiceover, although, as I said, Sennheiser MKH416, which is a shotgun, is also widely used for voiceover for reasons that I find inexplicable. Nevertheless, voiceover for the most part means large diaphragm condenser. So what is voiceover? Let's say you're listening to radio, and there's a commercial that says, "Hurry up, today only special sale, blah blah." Well, somebody has to read all this nonsense into a microphone, and actually it's not just some guy, it's a professional, and all he does is read into a microphone. He gets the text on a piece of paper that says what he has to say. It says, maybe has a note like sound happy or something, and says that it has to fit into, let's say, 15 seconds. And then he has to interpret how he should read it, and then he should read it, and most likely he has his own microphone because he wouldn't trust just a random microphone. He wants to make sure that he knows what the outcome will be, so he has his own microphone, which will usually be like $3,000 or so. And it's a professional tool for him. So this guy, who could potentially make as much as even $1 million a year, depending on his level. Some, of course, make nothing, but others make really good money. But bottom line is he's getting paid for the ability to interpret how he should sound, then deliver that sound, and as well record that sound through a microphone. So this is the most critical type of speech recording application for as far as microphones go. It is a speech recording application where you're actually getting paid for the quality of the speech. So you're not gonna take chances on a piece of garbage microphone when it's putting food on your plate. So what makes large diaphragm condenser microphones so well suited for this? We'll talk about this right now. So in part 1 of this video, we've established that dynamic microphones like RE20 dominate radio broadcasting on AM, and I gave you some reasons for that. Now we've established that large diaphragm condensers dominate voiceover. So I guess now I have to give you reasons for this. If you're guessing it has something to do with large diaphragm condenser having a large diaphragm, you are correct. However, of course, that's not a good enough explanation. So let me first tell you about the differences between speech as a material and the other common type of material that's recorded, meaning vocal singing. When you sing, you essentially raise your voice, and it does two things primarily. Is that it increases the amplitude of your signal, of your voice, and also it squashes the frequency range towards mid-range. Now, why does this happen? In your speech, you have vowels and consonants, and vowels are the low-frequency sounds, and consonants are the high-frequency sounds. However, when you raise your voice or you sing, vowels dominate the consonants, so high frequencies become less important. And vowels themselves move up in the frequency range from lows into the mid-range, because that's just how voice works. When you strain to make it louder, it moves up in frequency. So you in vocals get, as I said, narrow frequency range and high amplitude, and in speech you get low amplitude and wide frequency range. So obviously it's much more complicated for a microphone to pick up lower level signal which extends over wider frequency range. And as well, a speech is probably the kind of signal that your brain is best at analyzing. Therefore, if you record the sound of something like a school bus driving by and it's really bad recording, the brain wouldn't really care because it doesn't really understand how a real school bus is supposed to sound that well. But the brain knows perfectly what voice should sound like, and if you screw it up, the brain is gonna know that you screwed up. So there's really an uphill battle for the voiceover microphone to capture a low-level signal that's spread over a wide range of frequencies and that the brain is really going to scrutinize. And this tends to be the reason why large diaphragm condensers or voiceover microphones tend to be quite expensive. So next we'll talk about their construction. So how are large diaphragm condensers constructed? Well, actually it's quite a bit different from pencil microphones. It's not just the size of the diaphragm. Actually, most large diaphragm condensers use a dual diaphragm capsule. So you don't just have a diaphragm that's large, you have two of them, one in the front, one in the back. The capsule actually looks symmetrical, front and back, and electrically the front and rear parts of the capsule hook up symmetrically as well. Each one has its own circuit, which you can already probably tell contributes to the high price. Also, instead of mounting the whole thing in a tube, it's suspended on elastic shock mounts inside an acoustically open grill. So that's also more expensive. So pretty much everything is more expensive about large diaphragm condenser. But why would anybody need two diaphragms? Well, earlier I told you that pencil microphones come in various pickup patterns, such as cardioid or hypercardioid. Well, with a dual diaphragm condenser, you can electronically switch between all of the patterns, except shotgun. So you can have omnidirectional figure 8, you can have cardioid and hypercardioid. And you can have anything in between those. So for example, I'm using a wide cardioid right now. So this is a pattern that's in between omnidirectional and cardioid. And the way it's done, the way the switching is accomplished is by combining the signals from the front and rear part of the capsule at different ratios and also with different polarities. So let's say if you combine front and back in phase, you get omnidirectional. And if you use only the front, you get cardioid. Also, inside of the capsule, between the two internal back plates, there's gonna be acoustical channels which will provide damping and phase delay for the capsule. So the whole thing can get pretty complicated. Between all the electronics with 2 circuits, the switching, the air pathways in between the 2 backplates, the shock mounting, the acoustical grill, it starts to get expensive, and that's why there are not really any serious large diaphragm condensers for less than about what this one costs, which is about $800. So for the most part, if you're looking at a large diaphragm condenser, you're looking at $1,000+, while with a pencil microphone, you're looking at about $300. So there's quite a difference there. But actually, a large diaphragm condenser doesn't have to be a dual diaphragm design. It can be a single diaphragm design, but then it's not going to be able to switch patterns. Well, most people, or rather many people, don't need to switch patterns, and they would gladly buy a cheaper microphone with a single pattern. So some of these single pattern microphones in large diaphragm condenser version, some of them will be just like the dual diaphragm version, but simply with the rear capsule disconnected, rather with the rear diaphragm disconnected, and half the electronics basically missing. So that's if you get that, that's a pretty good scenario. But unfortunately, oftentimes the manufacturer will like to save some money and also save some on the internal design of the capsule, and instead of simply disconnecting the rear part of the capsule, they're actually going to make a completely new capsule for the single diaphragm version, and they're going to tell you that it's just the same as the real one, but it's not going to be, and it's going to sound worse, and all the development money is going to go into the dual diaphragm capsule version, because that's where all the profits are going to be at. But for people who can't afford the real microphone, they're gonna make a single diaphragm version, and they're gonna tell you that it's the same, that it sounds the same as the other one, but it really does not, because they cut some corners somewhere, and they're not gonna tell you about it. So anyway, that's just how it is. This video is getting too long again. I know I said I will explain why large diaphragm condensers are more suitable for voiceover, and I will explain this, but I'm afraid that this and a lot of other things that I didn't have time to go into are going to have to wait until the next part of this video. So see you then.